Alright guys, so this video is going to be about isotopes. So at the top of page 230, it says two atoms with the same number of protons and electrons, but different number of neutrons are called isotopes. So that's really the key, the different number of neutrons. So if I look at the periodic table, let's talk about carbon. Carbon has 6 protons. The atomic number is 6, so it will always have 6 protons. That is set in stone. There's no way around that. But it can have a different number of neutrons. It can also have a different number of electrons, right? That's when we're talking about ions. So fluorine, for instance, 7 valence electrons. So it can gain an electron to fill its valence shell. So a very common way to find fluorine is when it has an extra electron. So it would become fluoride ion, 10 electrons, minus 1 charge. But it will always have 9 protons, right? If the atomic number is 9, there'll be 9 protons. The mass of fluorine that's given on the periodic table is 19 exactly. So that would suggest that essentially all of fluorine is in the isotope where 9 protons and 10 neutrons come together in the nucleus to give us an atomic mass of 19, right? 9 plus 10 equals 19. So fluorine looks to me like it's probably 100% fluorine 19, where I've got 10 neutrons. Other things can have different numbers of neutrons, and we can't predict the number of neutrons that we're going to have. It's not always going to be the same number of protons. It's not always going to be 1 more or 2 more. It's totally variable, so there's no way for us to predict that. We can figure it out based on the periodic table and things like that. But there's no way for us to predict it, is really the take-home message. So we talked about some of this in class, but let's start with number 8. It says the number of protons and neutrons for C14. The number of protons has to be 6, right? Carbon is atomic number 6. It's got to be 6. To find the number of neutrons, all I'm going to do is say, well, how many neutrons do I need so that these two numbers add up to 14, right? 6 plus 8 equals 14. So that's going to give me my C14 isotope. Now, down here, what this is talking about is the natural abundances. So if I have a sample of carbon, some of that carbon will be C12. Well, really most of it. Natural abundance, 98.8%. So if you have 1,000 carbon atoms, 98.8% of that 1,000 carbon atoms will be C12. So when I say C12, this is my picture, okay? So in my C12 nucleus, I've got 6 protons. So if you count the positive charges here, there's 6. And then my empty things, circles, those are my neutrons. So 1, 2, 3, 4, 5, 6. 6 neutrons, 6 protons. That's my C12 nucleus. I've also shown my 6 electrons floating around outside. My C13 is just going to be where inside of the nucleus, right? 1, 2, 3, 4, 5, 6 protons, 1, 2, 3, 4, 5, 6, 7 neutrons. So C13 is going to weigh a little bit more. It's going to have the same number of protons, same number of electrons, but all we've changed is the number of neutrons. So this is an isotope, right? That's really the take-home message here. So what this chart is telling us is if I do have 98.8% natural abundance, C12, how many carbon atoms is that going to be out of 1,000? So the way that I would calculate this, I would say, starting with 1,000, I'm going to multiply that by 0.988, right? If I do 0.988, that's 988. So hopefully you guys can see that. And I can do the same thing for C13 and C14. So again, 1,000 times 0.011, that's 11. And then 1,000 times 0.001 is 1 for C14. Now if I add all these numbers together, 1 plus 11 plus 988, that should equal 1,000, right? So in my 1,000 atom sample, 988 of them will be carbon 12, 11 of them will be carbon 13, and only 1 of them will be carbon 14, where it has that extra neutron. Okay, so let's turn the page. So this question says, what would be the mass of the entire sample? So to figure that out, it gives us a formula to use, but I'll just rewrite it here. 988 times 12 plus 11 times 13 plus 1 times 14. And if we do that calculation, 988, times 12, 11 times 13, and 1 times 14. Now I'm going to add all those together. So 14 plus 143 plus 11856 gives me 12013 AMU. So what this represents, right, is this is the total mass of all 1,000 of those carbon atoms. Now if I divide that by 1,000, that's going to give me the average mass for one carbon atom, and that's 12.01. So that's why on my periodic table, my mass for carbon is 12.01, right? Because we would say, well, if it's the number of protons plus the number of neutrons, they should all be even values, right? They should all be 0.00, right? Like oxygen, fluorine. But a lot of these, especially like chlorine, 35.45. So the point here is that these values that we see on the periodic table, those are the averages. So if I took an average mass of 1,000 of those atoms, these are the values that I'd get. The reason that we're not exactly right is because we're going to have different abundances of carbon 12, carbon 13, carbon 14, or whatever, right? Chlorine 35, chlorine 36. There's going to be differences. The last thing I want to sort of point out is this self-assessment. Now, I know that some of you guys want answers to these. You want to sort of check your answers. And I think that that's a good, desire. But really, when you're doing these self-assessments, you should be at the point where you know this is the correct answer. You look at this, you read this question, you say, I know that this is the correct answer, and I'm confident of that because of all the stuff that we did before. If you are not at that point, again, that's your responsibility to sort of say, yeah, like I have questions about this. When you fill out this table down here, I mean, this should be something that you just know. You say, okay, number of protons, I've got it. I can look up sodium. I know that sodium's got number 11. That's the number of protons, right? Assume each isotope has a neutral charge. Well, then the number of protons has to equal the number of electrons. That's 11. I'm good to go, right? That's what I'm looking for here, okay? So am I going to give you the answers? No, right? You should be able to get comfortable. And then once you have your answers, if you do want to check with me, that's fine, right? I understand you need that little gold star. You want me to stick that gold star on your forehead. So I'm happy to do that for you guys. But, really, when you're doing these self-assessments, your goal should be to know what the answer is. All right, I think that's it for videos for today.